So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now today we're going to talk about what to do when your air conditioner breaks. It's not a question of if, but it's a question of when. The ACs always seem to break during heat waves when you need them the most. The units aren't regularly used and then suddenly they're overworked with really, really hot weather. So when your air conditioner breaks, it's a good opportunity to improve the comfort in your home as well as reduce your annual energy costs by putting in a heat pump, which is going to do both air conditioning and heating. So this is candid advice that we've developed over the years to kind of help you when your air conditioner dies, what to do. And that actually happened to me about 5 years ago. On the first really hot day in this new old house that we had, I turned the air conditioner on, nothing happened, went outside, there was voltage there, the thing just wouldn't start. Obviously, we didn't test it when we bought the house. And I was like, all right, scratching my head. I can just replace the air conditioner, but I still have this old 10 or 15 year furnace. Or this is an opportunity for me to put in one unit that's going to do air conditioning and heating. And from a savings, a comfort, and health standpoint, 5 years later, it's one of the best home improvements I ever made. Solar was the first. But I remember when I first turned the system on, my wife and I was like, it's not making any noise. We didn't even hear the airflow. It was so quiet. The unit outside was quiet and the air inside the house. So when you're kind of at that choice, unfortunately, where your air conditioner doesn't work and it's really hot, you have two options. You can just replace that outdoor air conditioner unit with another 20th century appliance, another one of those big, round, cylindrical, noisy air conditioner compressors. Now, those systems aren't as efficient. They're more costly to operate. Yeah, they're a little bit of a pain in the neck, and they're bulky. Or you can replace that air conditioning unit with a 21st century heat pump unit. High efficiency, cheaper to operate, more compact, and they can easily run on clean rooftop solar. And the coolest thing about it is that they can both heat and cool your house. They work like a furnace and they work like an air conditioner. Now, candidly, just replacing the air conditioner is the cheapest alternative. But when your gas furnace dies, maybe 5 years later, maybe 8 years later, you're going to really wish you installed a heat pump because you're going to have the same decision process. You're going to say, gee, now's not a good time to put in a heat pump because I got a relatively new air conditioner. Best thing to do is when the AC dies or the furnace dies, you might want to consider that. Just put in a heat pump, get it out of the way. The heat pump is also going to improve the comfort and the safety in your home. It's going to be warmer, it's going to be cooler, you're going to spend less money on your heating, your electric bill will go up, but your gas bill is going to go way down. And currently there's some really good tax credits and rebate incentives for heat pumps. So quick overview on heat pumps. Here's a picture that we typically use. There's two kinds of systems. There's a ducted system, and if you look at the lower part of the house in this illustration, you see red and blue ductwork that's running kind of throughout the house. And then in this example also, on the second floor of the house, we have what are called mini splits. And you can do it either way. That's very, very flexible. So there's those basically two systems. A mini split system where you don't have ductwork. It's also called ductless, or a ducted system that could use existing or new ductwork. So the simplest design uses a heat pump connected to the existing ductwork in your house. You have an outdoor compressor unit. And these compressor units with heat pumps, they're not these big round things. They're usually compact rectangular things. Smaller ones actually hang on the side of the house. Bigger ones may go on a little bit of a portable concrete pad outside. And then indoors, instead of just a vent, you'll have a fan unit with heat exchanger coils, and that's typically called an air handler. And the compressor is going to be connected to that, and that air handler is going to blow, depending on the season, hot air in the winter and cool air in the summer. Now, the cool thing is there's a reversing valve. So in the winter, you're pushing hot refrigerant through to the air handler, and you're pushing hot refrigerant up into the mini splits at the top. And then there's a reversing valve in the compressor. Just basically reverses it. Instead of sending hot refrigerant in the winter that's going to blow warm air, It reverses, and then it pushes cold refrigerant, really cold, it's like a refrigerator, cold refrigerant to the air handler or to the mini splits, and that's going to give you your air conditioning. Very, very cool. And that's why it's just kind of like one unit, and it does double duty because you've got this reversing valve. Now, that's basically for the ducted systems. Ductless systems have multiple small air handlers, sometimes one in every room, or fan units, and that's what people refer to as mini splits. These are typically installed flush in the ceiling or surface mounted at the tops of walls. And if you've been in hotels, and these things are becoming pretty common, you might see that. And each one has its own little remote control thermostat, so you can really control it pretty carefully. Typically, you'll have one of these mini splits per room, and each one of these mini splits has a fan and it has a heat exchanger. And you've got hot or cold refrigerant coming from the compressor to each one of those units. Very, very simple, very, very elegant, work really great. Okay, that's the overview. Now let's talk about kind of the thinking process, the upgrade process that you may want to go through when your air conditioner dies. So step one, what are the major issues? Well, obviously, it's really hot in the house, no air conditioning. But are there other comfort problems? And this is where having the right contractor that's going to ask the right questions, not only can they kind of solve your emergency, but they can make sure that your home is going to be safer and more comfortable. Do you have some rooms that are too hot or too cold? Is the air too humid or too dry? Does the air conditioner or the furnace cycle a lot? They call it short cycle. It turns on, it blows a lot of hot air, a lot of cold air, and then it turns off and then it waits and turns on again. You really want something that's going to run in a more balanced way. And the new heat pump systems with these variable speed fans, that's why they're a lot more quieter and a lot more efficient. Another question you may have is this the time that you want to start electrifying your house? Now, a lot of times people don't electrify their whole house at once. It's a big project. I went through it. But the ideal way to do it is you electrify your house kind of step by step as your old appliances die. When your air conditioner dies, it's the best opportunity to put in a heat pump. And the electrification is going to save you money. If your furnace is over 5 years old, it might make sense. There's some regulations in California and maybe other states that after 2030, you're no longer going to be able to buy a new gas furnace. It sounds kind of aggressive, but it's the right way to go from the state's perspective, because heating with natural gas is one of the biggest contributors to global warming, especially emissions in California. So if you have, it's 2024, so 6 years from now, if your furnace dies, you're not going to be able to get another furnace. You're going to have to put it in a heat pump. Now, it's going to make sense to put it in a heat pump, and it's going to be cost effective, but might as well just kind of get it out of the way now. Now, when you're also doing electrification, you want to consider integration with other electrification measures. Maybe it's the right time to put in more solar panels or add a battery storage system, or maybe it's time to upgrade your electrical service to handle new EV chargers you're putting in. So step one, just kind of figure out what the major issues are. Step two, get expert advice. And the best experts are really your local HVAC contractors. They're going to know the most, but you want to find local contractors that are very experienced with heat pumps. Now, many contractors, you call them up, you say, my air conditioner died. They're going to think, oh, well, this is a great thing. I'm going to go out, I'm going to give them a quote for a new air conditioner compressor. It's going to be a quick in and out, and I'm not going to have to spend a lot of time. So a lot of salespeople just like to just do a quick replacement. They may not really give you the straight scoop on efficiency and comfort issues. They're just going to want to install that quick system. So I'd suggest finding a contractor that knows something about heat pumps, knows something about electrification, and you're really going to want them to do a detailed site visit. They're going to want to look at the layout of the house. They're going to see the orientation. They're going to see what kind of heat loads you have. So you may have maybe some trees got cut down, and then you have the south side of your house is really hot right now. It used to not be that warm. So they're going to be able to kind of figure this out. And they'll also be able to give you canned advice on the age of the equipment. Now, we're talking a little bit about comfort issues. This is the time when you can put in a system that's going to operate more efficiently and give you better comfort. Are you happy with the current cooling in all the rooms in your house, the current heating in the rooms in your house? Are some rooms really cold and some rooms are not that cold? So these are adjustments that you can make with a new heat pump system. A lot of it has to do with the existing ductwork. So it's important to make sure that you have ductwork that's the right size to each area in the house, that it delivers the right amount of air. A big room with southern exposure is going to need more air delivered, more cold air delivered to it in the summer. And if it has a lot of windows, it may also need more air delivered to it in the winter. So that's where the ductwork and the balancing of the system comes in, and to make sure that those ducts are sealed well and not leaking and well insulated. The contractor should check your existing wiring to make sure that you have the proper code wiring. The wiring has to be up to code for the new heat pump unit. Usually, here in California, most states, the heat pump unit can use the same wiring, but it's something that we really want to check. Other parts of the country you may want to put in, you may need heavy duty wiring. If you don't have air conditioning, you're definitely going to need to add some wiring for that. The contractor can give you advice on the new thermostat. Usually you're going to put in a new thermostat. We like the Nest thermostats, and we also like the thermostats that come from certain heat pump companies that really have their own elegant, highly efficient thermostats that can use all the features of these new heat pumps. Now, when you put in a heat pump, if you have an old gas furnace, which is usually what's going to go out, you're going to want to think about what's involved in taking out that old furnace, taking out the old ductwork that may not be necessary. And in my house, we had a little bit of asbestos in the flue that had the exhaust from the natural gas furnace. That was something that the contractor was able to handle because according to contractor rules, if there's just a small amount of asbestos, good quality contractors can address it. If you have a lot of asbestos on a lot of old ductwork, that's when you may want to bring in an asbestos contractor. But your heat pump contractor should be able to give you the right advice on that. So one of the trickiest things is to figure out where you're going to locate the fan units or the air handlers and where you're going to put in mini splits. Because you want to make sure that you have enough hot or cold air delivered to each room, whether it's delivered from a mini split or whether it's delivered from an existing ductwork. And then, finally, we're going to want to make sure that the contractor's going to want to make sure that there's a good place to run any necessary wiring and refrigerant lines and maybe ductwork from where the equipment's located to where you need it. And contractors are going to try and conceal that ductwork as much as possible. Obviously, you want it out of the way, and you want to ideally reuse the ductwork, or at least the ductwork locations that you've had in the past. Step 3. Okay, so you got the advice. Get some bids from different contractors, and then hire the contractor that you think is going to do the best job for the right amount of money. And you're going to want to talk to a contractor that can do a good design. You can't possibly, this is kind of like doing battery storage. You can't possibly just hire a contractor from the internet and they're going to kind of figure it out and say, boom, here's the price. There's so much involved in actually crawling around the house, walking around the house, understanding where the equipment and the power and the ductwork is going to go. You can't just do that remotely. So the contractor will start, and you're going to work with the design that you accept, and they're going to do the system as you expect. And you want to also be able to evaluate the tax credits and the IRA rebate incentive. So there's $2,000 tax credit with the federal tax credit. Everybody gets it. It's really easy. The Inflation Reduction Act also has rebate incentives, but they're very complicated. There are also state-level incentives, also extremely complicated. There are multiple ones for every state. So finding the right contractor that knows what's involved in getting the incentives, if you elect to get those, then that's very useful. Get the contract signed, schedule the project. And the whole installation of the heat pump is only going to take a few days. Rarely does it take one. Usually it's like 2 or 3 days. Then there's going to be an inspection, if necessary, from the local jurisdiction. Maybe you have to get your ducts tested afterwards, but that's something that the contractor will automatically take care of. And step 4, finally, learn how to use the new system. It's like a gas furnace and air conditioning. Pretty drop dead simple. You have to set the thermostat the way you want, different temperatures for the summer versus the winter. And the only maintenance really is clean the filters based on the recommendation of the manufacturer. And also just outside, look at that compressor unit, make sure that there's no spider webs or bugs or bees or making a home in there. All right. So just to wrap up, when your air conditioner dies, that's the best time to get a heat pump. Find a contractor who's knowledgeable about heat pumps and home electrification. Typically, local contractors are going to know the most about local rebates and the tax credits. And just keep in mind, once you're done, you're going to have a more comfortable home and you're going to have lower utility bills. Okay, that's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. And if you missed any of today's show, you can go to the Energy Show website at energyshow.biz and listen to the podcasts.